per day, so they bought 2. So let's throw Nancy into the mix. The Orpington, a beautiful species for in town in Bend. Very, very fluffy, good in the winters, fantastic layers. These guys together, dark brown egg, light brown egg, she and Mary. I think Nancy's probably the best layer we have. She dumps out an egg, like 4 eggs every 5 days, even in her old age, which is fantastic. So very consistent. A whole flock of those things is really, really friendly. All right. What would a distribution for 2 birds look like? So we're building our flock. We're building my flock 1 bird at a time. How about flock number 2? Flock number 2. Anybody seeing that 1 and 3 come up yet? Anybody seen that 1/3 that I gave the guy at the store yet? No, haven't gotten to flock number 4 yet, which is all 4 birds. We'll get there. We might get there today. It might take us till next time to get there. Okay, now we're buying 2 birds. We're still interested in egg layers. That's still what I want. I want girls that are going to lay eggs. So I still want to know how many girls I'm going to have, plus the corresponding chance of that. So let's start by developing the left-hand column. How many girls can I get if I buy 2 birds? 2? 1?
None.
Or none. You might buy 2 roosters, right? Does that make sense? So clearly, the least number of girls I can have is 0. I might have 1 girl and 1 boy, and I might have 2 boys, or 2 girls, excuse me, 2 girls. All right. Who wants to take a stab at some probabilities? Who wants to take a stab at some probabilities? Give me a chance for one of those. I think you can do it. I think you can do it. What's the chance of any one of those 3 outcomes? I'll give you a hint. They have to sum to 100%, right? They have to sum to 100. So go ahead. I was interrupting somebody. Eric, go, my friend. 0.333. Where's the 0.3? Oh, because I told you the 1 and 3, right? Don't hold that one until we get to the 4th flock, which is all 4 birds. The 1 and 3 won't show up yet. It's only 2 birds. Hold that thought. You can calculate this based on what Kelly did up here at the front board a little while ago. Remember what she did? What did she do? She gave us the chance of all roosters, right? She did 1/10 times 1/10 times 1/10 times 1/10. That was for 4 roosters. Can we apply that kind of logic over here with just 2? What would it be?
1 over 100.
1 over 100. JT is where? Where?
For no females.
In order to get no females at all out of 2 birds, the first bird has to be a boy, which happens 1 in 10 times. Can I use decimals? Is that okay instead of 1 in 10? Is that okay? And the second bird has to be a boy, which happens an additional 1 in 10 times. What's 1/10 of 1/10? 1 yawn. Very good. 1 in 100. There's a 1 in 100 chance. Max is going to grab 2 boys. It's a pretty small chance. I would call that an outlier. If we pulled 2 boys out and got 2, or pulled 2 birds out and got 2 boys, I call that an outlier. And then I go back to the store and complain. Like, what the hell, 90% my butt. It's a 1% chance it should have happened. Of course, they would give me 2 birds. We actually had to bring back May and Fern. It's actually May 2 and Fern 2 in the new batch. May 1 was an absolute pain in my ass. She was attacking and pecking at the eyes of all the other girls. And we said, she needs to go away. And they said they have a bin at the store. What do they call it? They called it a timeout bin. And I was like, does the timeout bin go to Jeff at Reptile Zone? Just out of curiosity, when you're done. And then that was May 1. Fern 1, we got her home and she was like, she just kept laying on her side. I'm like, that one's not going to live through the night. We brought Fern 2 back. And they have a rehab bin. I was like, does that go to Jeff at the Reptile Zone too? And we got Fern 2 in May 2. So anyway, love this. 1 in 100. We got 99% more to attribute to these. Anybody want to take a stab on the other ones? Where is that? Oh, I love that. So, for 2 girls, we can apply 2 girls same way we did 2 boys, right? What's the chance of a girl? 0.9. What's the chance of 2 girls? 0.9 again. What's that end up being? 0.81. 81% chance. And Max is going to grab 2 girls. Yeah. So what do we do now? I heard Kelly's got to go for 0.1, 0.9 for the middle one. That makes sense, doesn't it? 0.1, 0.9. A boy and a girl. What's that going to be? 0.09? Yeah? Good. Check that. Except there's one small problem with it. Do you see the small problem? There's a teeny tiny problem. Tony's seen it.
Doesn't add up.
That one teeny tiny problem is it doesn't add up to 100%. Crap. Look at 1 plus 9% is 10%, plus 81% is 91%. We're off by 9%. Shoot. How are we off by 9%? What did we do wrong? The answer is nothing. We didn't do anything wrong. We just forgot to account for something. Kayla, what are you saying?
Margin of error?
Oh, good for you, sister. We can ignore margins of error because if I'm assuming that 0.9 is correct, there is no margin of error. Thank you for bringing that up. Bringing that up. There's actually a more fundamental thing we forgot. Does anybody see what it is? We can ignore that too for now. Anthony, I love what you just said. It's more fundamental than that even. So, in other words, look back up to that slide right there. Okay? Bertha, top left, Nancy, bottom right. If we say they're both roosters, Bertha's a rooster, Nancy's a rooster. Fair enough. If we say they're both hens, Bertha's a hen, Nancy's a hen. If we say, Zach, what do you got?
Talk about like the faces on the die, how you can change the 2 and the 1 and the 1 and the 2.
We gotta rotate the dies. Snake eyes, boxcars, this is one of the non-matching suits. So for example, Bertha's the rooster, Nancy's the hen. Haven't we forgotten a possibility? What if Bertha's the hen and Nancy's the rooster? So shouldn't there be another something in that category? It's like rolling a sum of 3 on the dice, 1 and 2, 2 and 1. So I think what we have to do is we have to do something else. If we put 0.1 first and 0.9 second, that assumes Bertha's the boy and Nancy's the girl. Can't Bertha be the girl and Nancy be the boy? So I'm gonna say this out loud. See if this makes sense. Either Bertha is the boy and Nancy is the girl, or, what does or mean in probability? Or mean, I'm being a total bastard right now. That's your first project. Total bastard, I'm bringing that back up. But it's important again. Bertha's the boy and, which means times, right, multiplication. Bertha's the boy and Nancy's the girl, or Bertha's the girl and Nancy's the boy. That little piece we just added on, what's that equal to? 9%. Boom! 18% total. 18% total. And that sums up to 100%. We're happy. Sarah, please.
I got the same answer, but did it a much easier way.
Tell me what your easier way is.
I added 0.81 plus 0.01 and subtracted from 100.
That's gorgeous. Can you hold that thought? That's going to, unfortunately, that's going to break down relatively quickly for us.
Yeah.
No, I love what Sarah just said. And who else is thinking the same thing? We just did an awful lot of work. We could have avoided all that work if we had just taken the 2 we knew and taken away. Can you see how it's going to break down pretty quickly, though, unfortunately? If we start adding more than one more bird, we're going to have too many variables for that. But Sarah, I love what you just did. As a matter of fact, I used that trick in the store that night with the guy to get the 1/3. I didn't do this entire distribution. I did part of one distribution and used your trick. But if we actually need each individual component, we have to analyze line by line. I love what you did. Much easier, right? Okay, so far? Okay, now, let's come and add one more bird. I forget who I added next. I think I added